In the vast expanse of the cosmos, the birth of a star is an event of extraordinary wonder. It is a process that spans millions of years, a cosmic ballet of gas, dust, and gravity. Each star's birth is a testament to the intricate and delicate balance of forces that govern our universe. Our own star, the Sun, embarked on its epic journey billions of years ago, arising from a cold, dark cloud of gas and dust known as a molecular cloud. These clouds are the nurseries of stars, vast regions where the raw materials of the universe come together. This cloud, a stellar nursery teeming with the building blocks of stars, was the cradle of our solar system. Within these nurseries, countless stars are born, each with its own unique journey and destiny. Gravity, the architect of the universe, drew the diffuse material inward. This force, though invisible, is the key player in the formation of stars, pulling together the scattered particles of gas and dust. Slowly at first, and then with increasing speed, the cloud contracted, its density increasing as the particles drew closer together. This contraction is a critical phase, setting the stage for the birth of a new star. As the cloud collapsed, it began to spin faster and faster, transforming into a swirling vortex of cosmic matter. This spinning motion is a natural consequence of the conservation of angular momentum, a fundamental principle of physics. At the heart of this swirling maelstrom, a protostar was being born. This young star, still shrouded in its cocoon of gas and dust, is the precursor to a fully fledged star. The intense pressure at the center of the collapsing cloud generated enormous heat, heating the core of the nascent star to millions of degrees. This heat is a crucial factor, as it ignites the nuclear fusion reactions that power the star. This was the first flicker of the sun's mighty furnace. From this point on, the young star would continue to grow and evolve, eventually becoming the brilliant sun that we know today, a beacon of light and life in our solar system. The proto-sun, a giant ball of hot, dense gas, continued to contract under its own gravity. This contraction was a slow and steady process, taking millions of years. As the gas particles drew closer together, their collisions became more frequent and more energetic, causing the temperature and pressure in the core to rise dramatically. As its core temperature and pressure soared, a critical threshold was reached. This threshold is known as the ignition point, where the conditions become just right for nuclear fusion to begin. The core's temperature had to exceed 10 million degrees Celsius for this to happen. At temperatures exceeding 10 million degrees Celsius, a remarkable transformation took place. Nuclear fusion ignited in the heart of the sun. This process marked the birth of our sun as a true star, capable of producing its own light and heat. Nuclear fusion, the process that powers the stars, is a cosmic dance of atomic nuclei. In this dance, hydrogen nuclei collide and fuse together to form helium, releasing vast amounts of energy in the process. This energy is what makes the stars shine so brightly in the night sky. In the sun's core, hydrogen atoms, the simplest and most abundant element in the universe, are fused together under immense pressure and temperature, creating helium and releasing a tremendous amount of energy. This energy is produced in the form of light and heat, which then travels outward from the core to the surface of the sun. This energy, radiating outward from the sun's core, is the lifeblood of our solar system. It travels through space, reaching the planets and providing the necessary warmth and light to sustain life. Without this energy, our solar system would be a cold and dark place, incapable of supporting life as we know it. With the onset of nuclear fusion, the sun entered a new phase of its life. It became a main sequence star, powered by the steady and sustained fusion of hydrogen into helium in its core. This phase is the longest and most stable period in a star's life cycle, lasting for billions of years. For billions of years, the sun has been bathing our planet in its life-giving light and warmth, making life on Earth possible. The energy from the sun drives the weather, powers photosynthesis in plants, and provides the heat necessary for life to thrive. It is the ultimate source of energy for all living things on our planet. As the sun settled into its long reign as a main sequence star, the remnants of the original molecular cloud that had birthed it swirled around the newborn star. This disk of leftover gas and dust, a cosmic scrapyard, became the birthplace of the planets. Within this protoplanetary disk, particles of dust and ice drawn together by gravity began to clump together. Over millions of years, these clumps grew larger, attracting more and more material, forming planetesimals, the building blocks of planets. Through a process called accretion, these planetesimals collided and coalesced, eventually forming the planets we know today. At just the right distance from the Sun, a small rocky planet formed Earth. This pale blue dot, bathed in the Sun's light, would become a cradle for life, a cosmic oasis in the vastness of space. In the early Earth's primordial oceans, life emerged. The exact mechanisms by which life arose from non-living matter remain one of science's greatest mysteries. Yet, from the primordial soup of organic molecules, the first single-celled organisms emerged, harnessing energy from their environment and replicating themselves. Over billions of years, driven by the forces of natural selection, life on Earth diversified and complexified. From single-celled organisms to multicellular life, from simple invertebrates to complex vertebrates, life evolved and adapted to every conceivable niche on Earth. The story of life on Earth is a testament to the power of evolution, the remarkable ability of life to adapt and thrive in the face of adversity. And at the heart of this story is the Sun, our constant companion, providing the energy for life and shaping the destiny of our planet. Section 5. The Sun's inevitable fate. The Sun, like all stars, is not eternal. It has a life cycle, a beginning, a middle, and an end. This journey, though spanning billions of years, is a testament to the dynamic and ever-changing nature of the universe. It is a giant ball of gas, primarily hydrogen and helium, powered by nuclear fusion. This process, where hydrogen atoms fuse to form helium, releases an immense amount of energy, which we perceive as sunlight. But like any fire, it will eventually run out of fuel. As the Sun ages, it gradually consumes the hydrogen fuel in its core. This consumption is a slow and steady process, taking billions of years. The balance between the gravitational forces pulling inward and the pressure from nuclear fusion pushing outward keeps the Sun stable. As hydrogen is depleted, the Sun's core contracts and heats up, causing the outer layers to expand. This expansion will lead to the Sun becoming a red giant, a phase where it will be significantly larger than its current size. In approximately 5 billion years, the Sun will exhaust the hydrogen fuel in its core and begin to fuse helium. This transition marks a significant change in the Sun's life cycle, leading to dramatic transformations. This will cause the Sun to expand dramatically, transforming it into a red giant star. Its outer layers will swell and its luminosity will increase, making it a bright but cooler giant. As a red giant, the Sun will engulf the orbits of Mercury and Venus, and Earth will be scorched and, well, uninhabitable. The intense heat and radiation will strip away the planet's atmosphere and boil its oceans. The once vibrant and life-sustaining Earth will become a barren, desolate rock. This transformation is a stark reminder of the impermanence of celestial bodies and the delicate balance required for life. Eventually, the Sun will shed its outer layers into space, creating a beautiful planetary nebula. This ejected material will contribute to the cosmic cycle, potentially forming new stars and planets, leaving behind a dense, hot core called a white dwarf. This remnant, though small, will be incredibly dense, with a mass comparable to the Sun, but a volume similar to Earth. This white dwarf, a stellar ember, will slowly cool over billions of years, gradually fading as it radiates away its remaining heat. Eventually, it will become a black dwarf, a cold, dark, and inert remnant of what was once a brilliant star. This final stage marks the end of the Sun's life cycle, a journey that began billions of years ago in a nebula far, far away. So, what if humanity could venture beyond our solar system? Imagine the possibilities of interstellar migration. The challenges are immense, but so are the rewards. Could we find new homes among the stars, or perhaps even encounter other forms of life? The journey would require unprecedented technological advancements and a willingness to explore the unknown. Creating a roadmap to the stars isn't just about plotting a course through space. It's about developing the technologies and strategies that will make such a journey feasible. From propulsion systems that can achieve a fraction of the speed of light, to sustainable life support systems for long-duration missions, every detail needs to be meticulously planned. The roadmap is our guide to turning the dream of interstellar travel into a reality. With great power comes great responsibility, and the prospect of interstellar travel raises profound ethical questions. How should we approach the potential colonization of other planets? What are our responsibilities toward any life forms we might encounter? And how do we ensure that our expansion into space is done sustainably and equitably? These are the questions that will shape the ethical frontier of space exploration. As we look to the stars, we are not just seeking new frontiers, we are writing the next chapter of human history. The future of humanity could very well be among the stars, and the decisions we make today will determine the path we take. Will we rise to the challenge and embrace the unknown, or will we be content to remain earthbound? The stars are calling, and our future may be written in their light.